Okay, welcome to PreCalc section 2.7 day 1. At the end of this section, we'll be able to solve equations in one variable. I will be able to solve rational equations by multiplying by the LCD, eliminate extraneous solutions, solve rational equations by using substitution and graphing calculator. Okay, so we're going to do that solve rationals tomorrow, but right now what we're looking at is the idea that rational equations are equations involving rational expressions for fractions. And remember, the set of rational numbers is represented by Q, or the quotient, and every rational number can be written in the form of f of x over g of x equals 0. But because of that Q quotient, we're talking about Q of x would equal that f of x over g of x. So now, if f of x and g of x are polynomial functions with no common factors, then the zeros of f of x are solutions of the equation. To solve an equation involving fractional expressions, we multiply both sides of the equation by the LCD, least common denominator, to clear the equations of fractions. Sometimes the LCD contains variables. Okay, so keep that in mind as we're going. And remember, when we introduce a variable in our clearing with the LCD method, we may be introducing extraneous roots, and we should check our answers as we go. So as I'm looking at this one here, I'm going to multiply it by x, because this is x over 1 and this is the one I want to clear. So I have x squared plus 3 equal 4x. Now I will rearrange. I'm going to subtract 4x and add 3. And then I'm going to look for my zeros, because I can factor this. This is x minus 3 and x minus 1 equals 0. Using zero product rule, I've got this situation and this situation, respectively. So x is equal to 3 and x is equal to 1. So I should check my original relationship with the values I just found. Okay, so in checking, if I put 3 in for x, I will get that it is 4, so that checks out. And the other one, if I put 1 in for x, I find out that my answer is 4 as well. So I've checked it out, and my answers for this first problem are 3 and 1. Now, I could also put it in my calculator and notice where my graph crosses the x-axis, and found that my zeros, when that's where it crosses the x-axis, are actually positive 1 and positive 3. Now, as we keep going here, I have a binomial to multiply both sides by and a monomial. I'm going to be looking at, nope, excuse me, not the monomial. I'm just going to multiply both sides by x minus 4. Okay, so I got x minus 4. So x times x minus 4. And when I go x minus 4 times 1, well, I'm going to do that here. X minus 4 up top and over x minus 4. Okay, and anytime I multiply the LCD, I'm really multiplying the numerator, and then I divide it out with the denominator, so that's going to be equal to 0. So now I've got x squared minus 4 plus, minus 4x plus 1 for this answer. Now, in situations such as this, I can't easily factor it, but I can complete the square. So in completing the square, I have x squared minus 4x plus something, and I'm going to push that negative 1 to the other side. But in completing the square, I take my b term, that term, and I cut it in half, and I square it to find my third member of my trinomial. And half of negative 4 is negative 2, squared is 4. So I am adding 4 to both sides. I'm introducing 0 to the problem, and it's going to make a different look. So now I can factor, because it's a perfect square, x minus 2 squared is equal to 3. And I solve, so I've got x minus 2 is equal to plus or minus the square root of 3, and I have 2 plus or minus the square root of 3 as my possible solutions. So I've got x plus the square root of 3 and x minus the square root of 3. As I check this problem, with the solution itself, I've got to know that I'm going to go back to the original problem, and I've got my x plus 1 over x minus 4 equals 0. So I've got 2 plus the square root of 3, that's x, plus 1 over 2 plus the square root of 3, minus 4 equals 0. I plug this in my calculator and I find out that this value evaluates to be 0. So I check that out. Well, I'm going to check the other one. And in my calculator, I bring back the problem I put in initially, and I just change my signs. So I go in and change my signs, and I have a sign change. Minus 4 equals 0. Now I check this, and this part evaluates my calculator, and I get 0 again. So that checked out. So this is my answer as far as my zeros, and I can check graphically on my calculator, or maybe not, because I got rid of it. So I can check graphically on my calculator what that value is. Now, as we move on, I talked about extraneous solutions being introduced when I multiply things across, and we will find extraneous solutions in examples 3 and 4. When multiplying or dividing an equation by an expression containing variables, the resulting equation may have solutions that are not solutions of the original equation. These are extraneous solutions. For this reason, we must check each solution of the resulting equation. Okay, back into the original equation to make sure the solutions we find are solutions at all. So I got my original equation, and we factored this on problem 1, x squared minus 4x plus 3. So I already know that this is x minus 1, x minus 3. Okay, now I can rewrite these. And let's just rewrite it this way. I can look at it and say, okay, so I've got 2x over x minus 1 plus 1 over x minus 3. And I've got this equal to 2 over x minus 1 times x minus 3. Okay, now if I multiply this by the same value, x minus 1, x minus 3, I will get, in my first term, the x minus 1s will knock out, and I got 2x, x minus 3. And my second one, the x minus 3s knock out, I got plus x minus 1. And then the last thing, I've got 2 divided by x minus 1 times x minus 3, so those will be gone, so it'll just equal 2. So now I'm going to distribute 2x squared minus 6x plus x minus 1 and subtract 2 equals 0. So I got that stuff on the same side. And as I'm looking at this, I've got 2x squared minus 5x minus 3 equals 0. And I factor 2x and 1 and x and 3, so I'm looking at this. And I've got a negative 3 and a positive 1. And I'm going to double check. Negative 3 times 2 is negative 6. Add 1 is negative 5. So I have this as my factors, and now I'm going to check for my zeros. So I've got 2x plus 1 is equal to 0, and 2x is equal to negative 1, so x is equal to negative 1/2. And then I'm looking at x is equal to 3. Now, I shouldn't say it that way. Let me tell you what I was thinking. X minus 3 is equal to 0, and x is equal to 3. So these are my two solutions I'm going to check. My first one I'm going to check is, that's the fastest one. I pop this into the original equation. Do you notice that 3 is x, and if 3 is x, I'm dividing by 0? So this is an extraneous answer. And it is not a 0 at all for this problem. Now I've got to look at 1/2. So I'm going to get myself a little bit of room to talk about the 1/2, so I got some room here in the original equation. So I've got 2 times negative 1/2 over negative 1/2 minus 1 plus 1 over negative 1/2 minus 3 equal to 2 over negative 1/2 squared minus 4 times negative 1/2 plus 3. Okay, so now I've got negative 1 up top, and I've got negative 3/2 on the bottom. That's 2 over 2, yep. Plus 1 over, I got negative 7/2 on the bottom, equal to 2 over 1/4 plus 2 plus 3. Now, as I evaluate, I got this is 2/3, positive 2/3, plus, or excuse me, minus 2/7, okay, equal to, that's going to be 5 1/4, that's 5.25, so it's going to be equal to 8/21 as we go through. So I've got 8/21. And now as I evaluate that, I'm looking at, well, I've got to make it 21. So I got 14/21 minus 6/21, and that equals 8/21. So that checks out too. So I've checked out that 1/2 is my answer, and x is -1/2 is my solution, and that's algebraic. And I can check to see that, hey, look, I got my -1/2 right there. Now I also noticed that my x minus 3 solution is a whole. Okay, so I found out that my whole of x minus 3, if I plug that in, I can know it's a whole. And how I can show that's a whole is by combining like terms, getting everything over and adding, and then I'll factor out that x minus 3 because that's removable discontinuity. But that's not what we're here for. We're here for extraneous solutions. So let's do number 4. And in problem 4, we're looking at the idea that I've got x plus 2, and x squared plus 2x. So now I'm going to multiply both sides by x times x plus 2. Okay, and doing this, I've got x plus 2 times x minus 3, and I got 3x, because the x plus 2 knocks out, and then plus 6. Now I combine like terms after I do my FOIL. I've got x squared plus 2x minus 3x minus x. So I'm just going to say I got minus x as I'm going. And I've got -6 plus 3x plus 6 equals 0. Now I'm going to combine like terms. The 6's are 0. And I got x squared plus 2x equals 0. If I use zero product rule, I have this situation. And x is either 0 or x is -2. Now, if I look back up in my original problem, when I use x is equal to 0, that becomes extraneous because actually x equals 0 is a vertical asymptote. And if I use x equal -2 in the original, I find out that -2 doesn't work out because that's also another vertical asymptote. So I have 2 extraneous roots, and so I have no solution to this problem. So both x equals 0 and x equal -2 are extraneous roots, or extraneous solutions. So the original equation has no solution. Okay, so that's what I've got for you all today. So keep that in mind as we're going. If you got questions, get them asked. And here's today's assignment. We got 1 through 30 odds. Let's kick out the 51 because I'm going to do that tomorrow. And we will talk to you tomorrow. Hey, you guys have a great weekend or great day, however it is on the, wherever you're at. Talk to you soon.